All right, we'll see how this goes. Unit 11, final unit. Using a polar grid, plot the given point. So remember, it's r theta, length of your radius, spinner hypotenuse, how far to spin your spinner. So 2 pi over 360 times 2 is 120 degrees. So our spinner, this is 1, this is 2, this is 3, this is 4, this is 5, is 2 units long. So it's right there. Spin it 120. So we're going to go 90 plus 30 is right there. There's point A. Let's go on to this one. My recommendation is to think of this as 30 degrees, and then we'll do that last. So our spinner's 1 unit long. We spin it 30 degrees, and we stop. The problem is there's a negative there, which means polar opposite. So if you can follow this line, you're going to go the opposite side, and there is point B. 4 pi over 360 times 5 is 300. So my spinner is now 4. I got to go up. We know this is 270 plus 30 is right here. So that would be point C. Got some more for you. Pi over 4 is 45 times 7 is 280 and 35. That's 315. So I'm going to focus on just the 3. So my spinner's 3 units long. I spin it 315, which is 270 plus 45. But don't stop there because of the negative. So I go polar opposite, and remember it's 3, so that would be out here. So that would be point D. This one, 5, so my spinner's 5, just says down 45. This is not polar opposite, it's just down 45. So that would plunk us right there, letter E. And then this guy, ignore that, don't ignore this. So this is 30 times 5, it's down 150, and my radius is 2. So radius is 2, down 150, that's 90 plus 60, which would take me here. But then I need to go polar opposite to right here, F. There we go. State 2 other ways to write the given polar point in polar coordinates. Radians. So let's stick with the program. So let's first of all take a look. Well, 6, and that's 45 times 3, which is 135, which means to there. And this might help. So what's a different way I could write it? Well, 6, and if I just kept going another 360, so that'd be 3 pi over 4 plus 2 pi, and then just find common denominators. That would just be 8 pi over 4. So that'd be 11 pi over 4. That'd be a different way to hit it that way. Another way we could do it, and this is what they're digging for, I think, is to get a point down here and then make the R negative so it goes all the way back there. So that would be 6, spin it down 45, so negative 45, but then that would stick us there. We need to give this thing instructions to go back here, so we'd have to put a negative there. And there's more than that, but I'm going to call that good. This guy, we got a spinner of 1. I'm going to make that very long. 60 times 5 is 300, so that's 270 plus 30, so it's going to stop right there. Not a horrible idea to just label your stuff. Might help you. So if this is where 5 pi over 3 is, if this is unit 1 length, or unit of 1, then another way I could do it is just take the same spinner, 1, and just go down 60 degrees, so negative pi over 3. But I think the one they're trying to get you to think about is this. So how could we get our spinner to go here? Well, that'd be 90 plus 30, which is 120. But then we would, so that would be 2 pi all over 3. But then if this is a 1, we'd have to tell it, don't stop here, go back. So we'd have to put a negative in front of that. And there would be our two other answers. Okay, transform these rectangular coordinates into polar. Remember, there should be 2, so be prepared for that. If it's multiple choice and they don't have 2, I don't know what to tell you, but be prepared for 2. So if we took a look at this, negative 3, 3, and there's our rectangular coordinate, we know that that would have to be a 45-degree angle here, which means this is 45. And if we know that this is 90, we can already see our spinner, look at all this information, negative 3, 3, would have to be 3 square root of 2, which is r. So that would be 3 square root of 2, and then it doesn't say in radians, so that'd be 135. Naughty me. But then another way to do that is to spin it down here. Maybe we could go 315, or we could go down 45. Your call. But we got to make that negative 3 square root of 2 negative 45. Because if we spun a 3 square root of 2 down 45, and then we'd have to go over here, we'd end up in the same spot. That's what they're going for. Okay, let's tackle letter B. So now we've got a different scenario. We got 2, 1, 2, and then up 2 square root of 3. You can see what they're trying to build here. 2 this way, 2 square root of 3 that way. This is 60, this is 30. So here we go. If that's 2, this would have to be 4. Don't panic, Connor. We got a spinner of 60, radius 4. So 4 pi over 3. We'll do this one in radians. But then the other one I'm sure they're digging for is this one. I'll make my drawing a little bit more accurate. This is also 60. So if we spun our spinner 240 but made it negative, that would mean go here and then come back, polar opposite. Well, how far did we go? We went 240, which is 60 times 4, so 4 pi over 3. So there's two other polar coordinates right there. Okay, so we go over to here, and we got 3, 7. Well, this one doesn't look so fun. So 3, 7, 1, 2, 3, 7, we'll just put it right up here. There's 3, 7. And we would have to get a little creative here because this does not fit into our comfortable little 30, 60, 90 world. We're going to have to go a squared plus b squared equals c squared to find our r. It's actually r. So that's 9 plus 49, which is 58. So we get the square root of 58. Now how do we figure out how far we spun it? I'm going to go tangent. I'm going to call that theta. Of theta is 7 over 3, opposite over adjacent, and I'm going to use my handy dandy calculator. Second tangent, 7 divided by 3, and I get 66.8. That's why they're giving us round theta to the nearest hundredth. That's 80 in this case. So our polar coordinate would be the square root of 58, and then 66.80, just following these instructions, which could be 66.8 in this case. Now, how are we going to figure out the other one, which is over here? Well, if that's 66.8, this is 66.8, we'd have to add that to 180, which would be 246.80, and then we'd have to make that negative square root of 58. Next one, transform the polar coordinates into rectangular. This is easier because there's only going to be one. So, spinner, 4. Spin that 270 degrees, which is right here, and it stops. That means the rectangular coordinate is just going to be 0, -4. This one, got to be careful. 1, spinner, 60, goes up there, and then stop. Don't do it. Don't stop. This is telling you the negative is saying go this way. So, if this is 60, this has to be 60. We know this is 1 still. And if this is a 30, 60, 90, and my hypotenuse is 1, that means this is 1/2, but it has to be negative. Multiply that by the square root of 3, negative square root of 3 over 2. So what's my rectangular coordinate? Negative 1/2, negative square root of 3 over 2 for that one. Letter C. This is 30 times 5 is 150. Spinner is 2. Spin that 90 plus 60, leaving me with 30-degree reference angle. Finish your triangle. We know our spinner's 2 units long, so we take half of that's 1. Multiply that by the square root of 3. Don't forget the negative. Negative square root of 3, 1. Okay, number 34A. Transform the given rectangular equation to a polar equation. So all we need to know is this is rectangular because it has x's and y's. We got to replace that with whatever it equals in the polar world. So it's 2r cosine theta. Replace y. 3r sine theta equals 10. Now, polar form does technically mean you're not done until you have r equals some stuff. So I don't know if the exam's going to get lazy or not, but we better not be lazy. So let's take the r out. We're left with 2 cosine theta plus 3 sine theta equals 10. Divide all of this by that, and same side, 2 cosine theta plus 3 sine theta. So r would equal that stuff, and that would be your answer. Sorry for being lazy, a little bit. X squared plus y squared is just screaming out, look at me, look at me, look at me. What are we going to replace that with? R squared. Just look at your little formula guy right here. And then we got y, which is r sine theta. Now, a lot of people want to divide everything by r. Don't you dare think about that. We're going to set this equal to 0 by subtracting r sine theta. Remember, we're not done until we got r equals some stuff. I'm going to flip this around, so r squared minus r sine theta equals 0. I'm going to factor an r out. And remember, there's something weird. Can our spinner, our r, be 0? No. So we can kick that to the curb and just focus on this. Add sine to both sides. And we get r equals sine theta. That's our answer for that rectangular equation. And now they're going to have us go the other way. Remember, we want r cosine, so we're going to stuff an r in there by multiplying this side by r. But if we do that to this side, we got to do it to that side, and look at it. It just works out. So this is x squared plus y squared equals 3x. That's all they want for that. Same thing here. I think what we'll do here, give me a second. Yeah, this one's just a little bit unique. So what I noticed was, if we could just simplify this a little bit by subtracting 4, we didn't have one of these on our homework. -4 sine theta equals -4. So a little twist. I'm just cleaning it up because I see that we can. And we end up getting that. Well, we're still in polar form. How do we get it to rectangular? Well, we need r sine, because then we can start replacing it with rectangular stuff. So we got to multiply that by r, but then we have to multiply that by r. So we get r sine theta equals r. Again, don't divide both sides by r, you'd be going backwards. We're trying to solve for, we're trying to substitute. I almost got twisted there. What does this equal? Well, yeah, hold on a second. I'm going to re-explain this. Dang it. All right, good lesson. Teachers are humans. I wasn't going in a good direction. So, here we go. Sticking with what I did before, I'm going to subtract 4, and negative 4 sine theta equals negative 4. I like what I did there. Divide by negative 4, divide by negative 4. There's a lot of creativity that is required on this problem, so bear with me. So it's like, wait a minute, what do I do with that? Well, if I multiply both sides by r right now, and that's what I attempted to do because I'm a creature of habit, and it worked over here, so I was trying it over here, that's going to take me down a little bit of a wild goose chase, down a rabbit hole, if you will. You could try it, see me, and talk about why it's not a great idea, but for the sake of this video, I'm going to show you what this problem requires that you do, and it's very strange. Sine, if we go up here and look at it, is we divide both sides by r. We can get sine can be replaced with y over r equals 1. Now, why would that help? Well, this gets very creative, but if we solve for y, we multiply by r. So I guess you know what? I was heading in a good direction. I'll show that to you if you want, but these cancel. I get y equals r. Now you're thinking, well, wait a minute, that's a little bit rectangular, a little polar. Correct. So now the trick is we're going to square this, and I'm running out of space, but I get y squared equals r squared, and now we can replace r squared with x squared plus y squared. Then the y squareds cancel, and we get 0 equals x squared, and we could leave it there, and we did it. So that's a bizarre problem.